aware with this fact that reservoirs are considered as one of the most important components of any reservoir development scheme. As it helps in regulating natural stream flow, they were modifying the temporal and spatial availability of water according to human needs. In the present context of water scarcity, due to continuously increasing rate of demands from various sectors on the reservoir systems, there are need for the application of efficient reservoir operation. Next slide, please. Now here comes the need of the research work. As multipurpose reservoir systems are subjected to intensive water management efforts, there are competing demands like from irrigation sectors, from domestic demands, from hydropower generation, and it has been observed since several past decades that a continuously changing pattern of various factors like temperature, rainfall, land use, land cover have been observed since several past decades. As a result of which here arises a need for the introduction of an efficient reservoir operation policies in the context of water scarcity. Objective of the study. The main objective of this study is to derive an optimal operating policy for different inflow conditions to the reservoir with trade-off between the hydropower generation and irrigation release. And the second objective is maximization of annual hydropower production subject to the condition of satisfying the various demands like from irrigation sector, domestic sector, industrial, and along with this the hydropower generation using a nonlinear programming method. Now coming to the study area, my study area is basically method reservoir, and here an optimal reservoir operation model has been developed and applied to the multi-purpose reservoir system named as method. It is basically located 48 kilometers from the Bath district, which is in Jharkhand, India. Next please. Now coming to the model formulation, this is the objective function for the maximization of hydropower generation. Next please. These are some of the constraints that must be satisfied for the application of the derived model. Like first one was reservoir mass balance constraint, second one is domestic and industrial demand, the upstream and downstream side of the reservoir. Fourth one is evaporation constraint, flood control constraints. Next is penstock capacity constraints, reservoir storage capacity constraint. So these are the constraints that I have taken and that should be fulfilled for the application of the model that I have taken. Next please. Now coming to the results and discussion. To derive various operation policies, the entire operation here has been divided into three different segments. That is pre-monsoon, monsoon, post-monsoon, and it was ensured that in each segment the percentage fulfillment of various demands was fulfilled, and correspondingly the dependable flow taken was 60%, 70%, 80%, and 90%. These are some of the trade-offs presented between the two conflicting objectives, that are irrigation demand along with the hydropower generation. Next please. For the different inflow conditions like 60%, 70%, 80%. The benefits of this trade-off and the establishing of this trade-off is that it will be helpful to the reservoir operators and decision makers about the compromisation that has to be done in one objective if an unit increment in any other objective is carried out. Now next, these are the graphical representation for the hydropower generation for different inflow conditions. This is the graphical representation for the reservoir, for the level that should be maintained in the reservoir for varying inflow conditions throughout the year. Now, coming to this is the tabulated form for the release of water that can be done from the reservoir system. Next, please. Now, summary and conclusion. From the study, this can be summarized that a wide range of research has been carried out in the field of reservoir operation rules, and it was found that the main focus of the researcher was maximizing hydropower generation only. But the new thing that has been done in this research work is that it incorporates the minimization of sediment yield also. Means along with the maximization of hydropower generation, it incorporates the minimization of sediment yield also. Therefore, this paper opens a new research field with the basic rules for hydropower generation. Next is conclusions that can be drawn with the study. An optimal operation policy has been developed for the Mehta reservoir. The derived policy is capable of producing maximum hydropower of 98311.05 megawatt per year. And the developed model can minimize sediment deposits, thus increasing the life of the reservoir. Thank you.
Okay. Thank you, Priti, for timely completion. Now, the last one will be presented by Ipshita Nandi. Mollusk as a tool for river health assessment, case study of River Ganga.